All right, guys, let's add to our notebook again. Now, we are starting like a little mini lesson, but it's so mini that it's not really worth it to get a new table of contents. So we're just going to add it to this. It's not even 3 sections. It's only 2. So what we're going to talk about is function operations. So essentially, the entire study of algebra is about functions, like different types of functions. And we've learned a lot of different types so far this year. We've talked about linear functions, we've talked about absolute value functions, piecewise functions, quadratic functions, polynomial functions, cubic functions, square root functions, and cube root functions are the most recent. And so when I say that we're going to do function operations, I mean we're going to take some functions that we know, and we're going to do stuff with them, like add them, subtract them, multiply them, divide them. Okay, so the last 2 pages we did was our solving on 79 and 80 here. So we just turn the page. We have this little guy right here, which if you want to like cut out these little flaps, you can do that. And I'm going to glue that one right in. What is happening? I got a page that's like falling out. And we'll just tape this in right here. And so, yeah, we have our function operations. Let me just readjust my camera just a smidge. Okay, function operations. So we are going to need some functions to work with. So if you remember, kind of appropriately write a function in function notation. So perhaps I have something like f of x equals x squared plus 6x plus 5. Cute little quadratic function. Probably do a lot of stuff with it. And then maybe we have another function, g of x equals x plus 1. Just a little linear function. Teeny tiny, okay? So if we're going to do some function operations, that just means we're going to maybe take those 2 functions. So remember, this is just the name of the function. So we're going to take the f function and the g function, boop, boop, and we're going to add them up. And what we're going to put into it is x. Now currently, right now, what's being put into both of these is x. So like it's not going to change at all. Another way to write it is to just say this f of x function right here, which is this. We are going to add it with this g of x function right here, which is this. Okay, so if we're doing addition, we're just going to take that f function, x squared plus 6x plus 5. We're going to take that g function, x plus 1, and just add them together. That's it. Like this one plus that one. And like we can't do too much. All we can really do is combine some like terms. So x squared plus 7x plus 6. Now the other thing that we could do that's slightly different is if instead I had said f plus g of 2. So instead of putting the x in here, instead of my input being x, my input is 2. I'm still going to add the functions, and I've kind of already done that, but I don't want x to be my input. I want 2 to be my input. So now we're just writing it as 2 squared plus 7 times 2 plus 6. And so I can kind of get like a final answer here. That's going to be 4. I was going to try to do it in my head. It was going to be a bad time. Plus 13 plus 6, so 24 overall. So this is just equal to 24. Okay, so kind of 2 different ways to approach a problem. I just keep an x in, which means I'm not doing very much, just combining some like terms. Or maybe I replace x with a number, I input a number in, and we get a value. Another thing we can do with functions is we can subtract them. So one way to write it would be to do f minus g when I'm inputting x, or f of x minus g of x. So again, using our same 2 functions, we're just going to subtract them. We're going to take that first one, x squared plus 6x plus 5, and then fully subtract the second one, which, like to point out, the addition, the parentheses around my 2 functions was kind of unnecessary. We didn't really need those. For subtraction, the parentheses around the second one is kind of necessary because I do need to subtract all of it. If I like kind of just put minus x plus 1, I might think that I'm only subtracting the x, but I do really need to subtract all of that function, so the 1 as well. So really it's just getting distributed in there. And like if I combine like terms, we'll have x squared plus 5x and then plus 4 now. So we subtracted 1. And again, if I wanted to do, let's say, f minus g of 3, well, now I'm not inputting x anymore. I'm inputting 3. And so I would have like 3 squared plus 5 times 3 plus 4. So 9 plus 15 plus 4, which is, OMG, 28. Just trying to do it fast in my head. Okay, so we can put a value instead of an x if we want. Another thing we could do is take our two functions and do multiplication. So if we put the little dot here, it means we're going to just multiply our two functions. So x squared plus 6x plus 5 times the x plus 1. And with multiplication, it's always important to put parentheses because if I'm multiplying multiple things, I don't just like kind of multiply one by one. I have to multiply all by all. And so like normally I would think FOIL, but since I'm doing 3 numbers times 2 numbers, I might actually set up a rectangle, like put them outside the box, get the numbers inside the box, like a 3 by 2, just so that I don't accidentally lose any numbers. So like that. And then I would just multiply to get each square. So x to the third, 6x squared, and 5x. And then across the bottom, we're multiplying by 1, so it's all going to stay the same. And then we can kind of combine our like terms. So overall here we have x to the third, 7x squared, 11x plus 5. And maybe just for time's sake, like, you know, we could do something like this where I do f times g of a number, and I would just like plug that number in. But I think you're getting it, so I'm going to maybe not do that. Just because like division and composition are a little bit trickier, I want to spend a little bit more time with those. These are all pretty straightforward. The reason that division is kind of tricky is because there are certain things I can divide and certain things I can't. Like if there's pluses and minuses going on, I probably can't divide too much. Also, I can't divide by 0. So like what this is showing me here is I want to do the f function divided by the g function, or f of x divided by g of x, but my g of x cannot be 0. That's super important to include because we're not allowed to divide by 0. Like the whole world ends, it implodes. It's terrifying. So we don't want to do that. So if we're going to write f of x divided by g of x, we have our f of x function, which is x squared plus 6x plus 5 over x plus 1. And because of all the pluses, I can't really divide anything here. If stuff was being multiplied, I could maybe divide. Like this is a little bit more than what you need to know right now. We're going to talk about this in a whole other chapter, but I could probably factor that numerator. Like what multiplies to 5 and adds to 6. If I did, that'd be 5 and 1. So we'd write it x plus 5, x plus 1. And now because I have multiplication in the top, I can divide out these entire factors, and we get x plus 5. Okay, so that's a thing that we're going to talk more about later. Don't super stress about it now. You probably don't need to worry about it right now. I just wanted to show it to you. We'll give you a little preview. However, the thing that you do need to include right now is that your denominator cannot be 0. So like looking back at my original problem right here, there is potential for my denominator to be 0 because x is changing. Like x can be whatever it wants to be. And so at some point, if I put something in for x, it might make this denominator 0. And I think the exact value that will make it 0 is -1. If I make this -1, -1 plus 1 is 0, and that's real bad. We don't want that. So we do have to include this as part of our answer. And how we're getting it is we're literally just taking the denominator and setting it equal to 0 and like trying to figure out what that will be. And whatever it is what I don't want x to be. So it's kind of weird. Like we're solving to find something that we don't want it to be. And that is part of my answer. So we're going to circle that up because we do need to figure out what can't make it 0 on the bottom. And then the last one we have here is composition. So composition of a function is kind of unique. It looks a little bit like multiplication, but it's an open circle rather than a dot. The way that we say this is g composed with f. And this is one way to write it, but this is the other way to write it. And so what's kind of happening here, remember, this is saying g composed with f when I input x. Now x is my input, and I can see that x is being input into f, and then the whole f function is being input into g. So that's really interesting. We're taking a whole function as an input. So if I think about my g function was x plus 1. But if my input needs to be the f function, then instead of x, what I actually need to write is my, is my f of x function, which was x squared plus 6x plus 5. And then I write the rest of the g function plus 1. And then I can do a little simplifying. So we'd have x squared plus 6x plus 6. And to kind of show you what this looks like if I compose with a number, so if I do g of f of 3, I'm going to input 3 into the f function. So 3 goes into f, so 3 squared plus 6 times 3 plus 5. So 9 plus 18 plus 5 is 32. Then 32 needs to go into the g function. So this went in here, and then my answer goes into g. And g is my input plus 1. So overall, this equals 33. So the way that I kind of think of a composition is I'm almost moving from the inside out, like the innermost parentheses to the outermost. And maybe let's try just a couple more like that. So if I had maybe some different functions, let's say I have f of x equals 2x plus 3, and g of x equals x squared minus 1. I don't know, just making things up here. If I want f composed with g of x, this is kind of how I think of it. I'm going to work backwards to forward. So x is going into g, and then that's going into f. Okay? So when I plug x into g, it's just this, x squared minus 1. But if I take this and put it into f, f's input right now is x. So this is going to be the input now, and it gets multiplied by 2, and then we add 3. And so then I can do a little bit. I can distribute here. So we'd have 2x squared minus 2 plus 3. And so 2x squared plus 1 would be sort of my final answer there. So weird. And then if I change it slightly again, if I do f composed with g of -3, okay, I'm still working backwards, but now I'm plugging in an actual value. So we're going to go -3 into g, and then that into f. So -3 goes into g. My input for g right now is x. I'm going to make it -3. So we'll do -3 squared minus 1. So 9 minus 1 is 8. And then that gets input into f, which f multiplies by 2 and adds 3. So 16 plus 3, so 19 is my overall answer. So kind of weird, backwards to forwards, and then we can reverse it up. So like if I reverse it up, if I go g composed with f of x, okay, so I just swap the order. X is going to go into f. So when I put x into f, it already looks like this, 2x plus 3. But then I need to take that and put it into g. And what g does is square stuff and then subtracts 1. So if I square that, I have to write it twice in FOIL. So 2x plus 3 times 2x plus 3, and then minus 1. And I'm going to kind of FOIL fast here. So we got 4x squared, 6x for 12x, and then plus 9 at the end, minus 1. And so overall, we're looking at 4x squared plus 12x plus 8. And then if I take that g composed with f, composed with, I don't know, -1, sure, funsies. Now I'm plugging in a number rather than just an x. So -1 is going to go into f. The f function multiplies by 2 and then adds 3. So we're going to do -1 times 2 plus 3, which is going to be -2 plus 3, so 1. And then that goes into g. And what the g function does is it squares things and then subtracts 1. So 1 squared is 1, minus 1 is 0. And so overall your answer is 0. Okay, hopefully that composition crash course at the end there helped a little bit. We'll see you in the next one.